almost every day.
Uh-huh. Okay. Let's tackle these problems. Shall we go? We'll go over the ones you missed.
It's only the ones we missed because I have to do corrections for them by tonight.
Okay. Whenever you have what I call double exponentiation, in other words, we have three things here that are, two of them are being exponentiated, and then we have the whole thing being exponentiated. The most important thing to realize is that that -2 affects everything in the parentheses.
Yep.
Okay? So let's just multiply that -2 by every exponent of everything in the parentheses. What do you get? Let's just write it one step at a time. You get 3 to the -2.
X to the -6. And y to the 2.
Okay. Now we need only positive exponents. So we got to get rid of these negative exponents. How do I do that? Draw a fraction line. Where does this one go?
Wait 1 sec. Let me get this down. Wait, what did you say?
Where does the 3 to the -2, which side of the fraction bar does it go on?
The bottom.
Okay, so that's 3 squared. How about the x to the -6?
To the bottom.
X to the +6, and the y squared?
Stays on the top.
And now we simplify. We get y squared over 9x squared. As long as you do it very methodical like this, you will not make any mistakes. And the key is to do it in a way that minimizes your math mistakes. And the secret to that is to do one step only. Notice I didn't even square the 3 until I got to the bottom.
Yeah.
Okay. Let's look at number 2. You do this one. Again, double exponentiation, so each term.
It would be 2 to the 4th times x to the 12th and y to the 8th.
Okay, that only needs one simplification. What is 2 to the 4th?
2 to the 4th is 2 to the 3rd is 8. 64?
16.
16.
If 2 to the 3rd is 8, then 8 times 2 is 16.
Oh yeah, true.
Okay, I don't need a fraction bar here because there's no fraction. If there was one, I'd have a 1 under it. Okay, so, all right, let's go to the next one. 3. All right. Now, there's no double exponentiation going on here. There's just a lot of negative signs. Okay? So what do we do with all these negative exponents?
Flip them.
Okay, so what do I get in the next step? Don't combine them and flip them, just flip them. I still have a -3 in the numerator. Let's go ahead and put our fraction bar down there. And what happens to this x to the -2?
Basically everything comes down to the bottom.
Okay, so I'm going to make that x to the positive 2. How about that y to the negative 2? That becomes y to the positive 2. This minus y to the minus 4, let's just take the whole thing down there. Hold on, let me look at this. That minus sign is not, I put it in parentheses, but it doesn't belong in parentheses. Notice. The way they gave it to you was like this, which means the minus 4 only applies to the y. So I'm going to bring the minus 4 down, but I'm going to leave the minus sign up there. Excuse me, I'm writing down here. Apologies. Okay. Now, I've still got a minus sign up here, right? Because that minus sign was not being acted on by the minus 4, so I don't move it down. Now, I've got this y to the minus 2 that I can move up like that. Isn't that what I have? I moved all 3 negative exponents to the bottom, and I had some positive exponents down there to begin with. There was an x to the 4th and the y to the 4th. And I got another y to the 4th now. Make sure you see how I got everything here. Is all I did was move the variables that had negative exponents to the other side of the fraction line, both in bottom and in top. And I'm left with that.
Okay.
Okay? Now I can start combining stuff. Right off the get-go, I can see that. Okay?
Okay.
Now I could have done that originally. I could have actually run a line through that, but I wanted to do this in a very methodical manner where you just can't make a mistake. And if you do it one step at a time, you won't make a mistake. What's left in the numerator?
Like 2y4s and like.
Hold on. The only thing I got left in the numerator is that and that. What's minus 3 times minus 1? What's minus 3 times minus 1?
3.
Okay, that's the only thing left in the numerator. Now let's start combining the denominators. What are these two x's multiplied together?
X to the 8th.
No.
You said multiplied together.
Well, the thing to realize about exponents is you never do with the exponent what you're doing with the underlying base. It's the underlying base that's being multiplied. In other words, I'm multiplying the x times the x, and I'm going to add the exponents. So it becomes x to the 6th. Just combining those two.
Yeah.
And how about the y's? Y to
So we're multiplying those?
distinguish between multiplying the bases and what you do with the exponents. We are multiplying the bases, so we're going to add the exponents.
Okay, but it's like in parentheses, so I
It doesn't matter. The parentheses are only there to indicate multiplication. That's all. In other words, I don't really need those parentheses. If I erase those parentheses, it's exactly the same problem. When you have two letters next to one another, multiplication is assumed. So I could put a dot there if you like. But the point is that I am multiplying the bases. And you never do with the exponents what you're doing with the bases. So I got to add the exponents. Y to the 8th. And there's your answer with all positive exponents.
Yeah.
Okay? only difficulty at all in this problem was how to handle that part right there. Because that's a little strange. They don't have parentheses around it. If there were parentheses around it, then I would have moved the minus y to the fourth, the other side.
Yeah.
Okay. All right, let's go down. But the key thing to remember is when you're doing something to the bases, you never do the same math process to the exponents. If I am multiplying the bases, I am adding the exponents. If I am dividing the bases, I am subtracting the exponents. Okay? All right, number 4. I feel like I should write it out before I even do the first step. Because see that dot right there? Not necessary. But doesn't change the meaning at all.
No.
Still multiplication. I'm still multiplying x squared by 2x. The bottom. Now in the bottom, I got a parentheses around this. Multiplication. What's the first step in all of these kind of problems?
Flip the stuff.
Not yet.
Distribute.
Distribute. In other words, remove these parentheses. Always get rid of and the parentheses are usually there because there's double exponentiation going on. In other words, this set of parentheses is there because this quantity, minus x cubed, is being cubed again. Okay, so let's leave the top alone and work on just the bottom. What is minus x cubed cubed? We're not doing multiplication here, we're doing double exponentiation, which requires you to multiply the exponent.
Do you keep it up there?
I'm trying to remove these parentheses.
Oh,
I have to multiply that 3 by that 3.
Negative x to the 9th.
There you go. Okay, now let's move. Now let's
basically turn the other exponents negative. So.
Well, we're not, okay, the other one, not quite, because we have to figure out how to handle that negative sign there. Remember that negative sign is to the negative 1. So there's all kinds of paths you can get to the final answer here. Okay? Let's next, okay, the numerator doesn't need anything done to it. There's no negative exponents in the numerator. Okay, so let's take this whole thing and instead of removing the parentheses, let's move it up top. And there's a reason why in this problem I want to do it this way, because now that becomes a 1, not a negative 1. And now it eliminates all concern as to how to handle that negative 1 times that negative sign. Okay, so now I've moved that whole thing to the top, and I'm going to combine it with minus x squared y to the 4th 2x. Now I don't need that 1, which means I don't need the parentheses. I can erase that parentheses, I can erase that, and 1 is implied. And I do need parentheses around that just to indicate that I'm not subtracting, I am multiplying. So that's where we stand at this point. Now let's simplify. Take all the x's in the numerator, combine them. What do you get? what you have is a minus x squared, you have a 2x, and you have a minus x cubed. Combine all three of those.
That combines into negative 2.
Hold on.
Negative x.
I got a negative sign there and a negative sign there, neither of which is being operated by an exponent. There's a difference. If I write minus x squared or if I write minus x quantity squared, those are not the same thing. This one, the x is being squared, and then I'm keeping the minus sign. This one, I'm squaring minus x, which turns into positive x squared. So you have to be aware of what your exponent is operating on. So I'm multiplying same bases here, right?
Yeah.
Okay, well, what I'm really doing is multiplying minus x by 2x by minus x. What do you get when you do just that part?
You get negative 2x.
No, the negative times the negative becomes a positive. So you get a positive x, there's a 2 in front of it, and then add those three exponents because we're multiplying three bases that are the same. They're all x. So add those three exponents, you get 6. So that takes care of that term, and that term. Now let's go to the y. What do we got in the y's?
Y to the 6.
Good. And now we still have our bottom of minus x to the 9th. So we have to combine those two terms. What do you get?
X to the 3rd on the bottom.
Correct. So our final answer is 2y to the 6th on the top, x to the 9th, x to the 3rd on the bottom, and this minus sign didn't go anywhere. It's still there. So I'm going to put it out in front like that. So that's our answer. 2y to the 6th over x to the 3rd with a minus sign in front. This minus sign could go in the denominator, it could go in the numerator, or it could go in front. Same meaning, all three cases. If you had a minus on the top and the bottom, then it would become a plus. But is there anything about this problem that confuses you? Because this is one of the more difficult ones we've done at this point.
No, but I just have to get it done because this is due like today.
I see. Okay. So, number 5, you get that right or wrong?
I don't know. He didn't specify, so, you know.
I don't see any minus. I don't see any minus 2. I see he circled minus 15. What does that mean? Did he subtract points?
I don't think so, so let's just keep going.
Okay, so let's do 6. Okay, so they want to find out what the value of that polynomial is when x is 3. Well, the easy way is... Oh, you got this one right also? Yeah, I'm sorry. You're doing it correct there. In other words, you're doing synthetic division, and whatever that last number you get is the value of that function at 3. Seven and 8 are correct? Must be. Yeah, already lost 8. All right, so 9. State the degree, leading coefficient, and constant. Also name the function based on degree and number of terms. Okay, it is a quadratic for sure. It's a trinomial for sure. Constant is -7. The degree is 2. What did you write there? I can't quite read it.
I can't either.
Looks like you wrote something squared. But I apologize totally. I wasn't looking at the function. The degree is 4. Notice the largest degree is in the middle. They kind of, in other words, if we rewrite the function in the order of degree, it's this. I apologize, I didn't see that. Not a quadratic. There's our function, right?
Yeah.
What's that called when it's to the 4th degree?
It's a quadratic, isn't it?
Quadratic, exactly. And it's still a trinomial, so that's good. Got 3 terms, that's what matters. The degree is 4. In other words, the degree is your highest exponent after it's been simplified. Okay? And the constant is -7. You got that right. IC, the number, what's IC mean?
I don't know. But I got it right, so it doesn't matter.
Okay. And you got 10 right, 11 right, 12 right, 13 right, 14, you lost a point. Let me see if I can figure out what you did on 14. Okay, factor each completely.
Well, it tells me what I did wrong. There's a little squared sign.
Yeah, I know. I'm trying to figure out how you got these.
I must have just not distributed correctly. So
That's 8/7, 8/7. So you used grouping, right?
yeah.
Let's go over that because here's the way we're gonna, oh, I see one of the mistakes. Well, no. If I'm
There's
gonna,
only one mistake.
I know, I'm just trying to figure out the solution and how you ended up without a v squared there. How much more?
Probably.
How much more do we have? Do we have enough time to cover all of these, or
No, we're not even gonna have close.
we're not going to have enough time to cover all of these? So you want to go to the next one?
Yeah, we're gonna do as much as we can.
All right. So the next one, 125x cubed plus 216. That to me looks like the sum of perfect cubes.
Yeah.
That is a perfect cube number. That's a perfect cube. X cubed is a perfect cube number, and 216 is a perfect cube number. So the way you do these is if I have a cubed plus b cubed, that's always factoring into a plus b times a squared minus ab plus b squared. Okay? So what is a? If that's a cubed, what is a? The easiest way to do these is to spell out what a is and what b is and then apply this formula. A is going to be the cube root of this. What's the cube root of that, what I have circled?
I don't know. 15.
5x.
Oh.
Notice that if you cube 5, you get 5, 25, 125. If you cube x, you get x cubed. So that's what a is. What's b? What's the cube root of 216?
I don't know.
6. Okay. Now that we've defined a and b, we can plug it in to that. Real simple. So what's my answer?
It's gonna be 5x plus 6.
And the other part, what's a squared?
5x squared.
Hold on, it's a squared. What's a squared?
5x squared.
Well, squared. Give me the answer. 5x squared is 25x squared.
25. Yeah.
Yeah, if you're squaring both the number and the variable, then go ahead and square the number when you write it down. Now, AB is what? What is AB?
30x.
And what is B squared?
36.
There's your answer.
Okay. Yeah, just keep going through these like without stopping, like
All
pretty
right.
much as quick as you
You're
can.
not concerned with learning it, just getting it right for the moment.
Yeah, because like this is just like a lot.
That's fine. I can deal with that. Okay. So here, x to the fourth. Did you miss this one or not? Yeah, you lost 1 point. That is like a quadratic. It's not really it is a quartic, but you'll see how I'm going to make it a quadratic. I'm going to treat this like something squared because this would be, I want to explain it to you because it's a hard explanation, but it factors. If I break the x to the fourth apart, if I treat it like a quadratic, I'm going to do that first, right?
Yeah.
Both signs have to be negative. And I'm looking for factors of 10 that add to 7, 5, and 2.
Okay.
That's the answer. Why'd she take off 1?
I'm not sure.
Probably because you didn't keep going. In other words, you can factor these also. This is x minus 5 times x plus 5. Excuse me, x minus square root of 5 times x plus square root of 5. This is x minus square root of 2 times x plus square root of 2. So she probably wanted that answer, given the fact that she took 1 off. I'm not sure what you did down here. Oh, I see what you did. Yeah, you got it all right. Except there's a plus sign there, not a negative sign, and there's a plus sign there, not a negative sign. In other words, when you set each of these to 0, you get x squared minus 2 equals 0, so you get x squared equal 2, x equals plus or minus square root of 2. That translates into those 2 answers.
Yeah.
Find all solutions. So she definitely wanted you to go through and fully factor it. First one you got wrong here is 7. Is that correct?
Yeah.
Okay, this is a very straightforward one. There are no negative exponents. I don't have to move anything to top or bottom. What is my net number on 7? Do the numbers first, then do the x's second, and then do the y's third. What's 3 over 12?
4.
1/4, like that, right?
Yeah.
Okay, what are the x's? You got it.
Oh.
X to the 6th.
Okay, x to the 6.
Okay. Hold on. Because x to the 4th times x squared is x to the 6th. And what are the net y's? When I take that y squared in the top and divide it by y to the 5th in the bottom, what do I get?
Y to the 3rd on the bottom.
Now, I don't need that 1 anymore. There's my answer.
Okay.
Number 8. very first thing to do to number 8, since everything is in parentheses and it's all being taken to the -2, let's apply our rules of exponents and take that -2 and multiply it by every number or every variable. So what do you start with in the top? 3 to the -2, right?
Yeah.
That leading 3 is also being taken to that -2. So that has to be applied to the exponent of the 3, which is a 1. Now apply it to the x squared. What do you get? Multiply the exponent.
8.
What's -2 times 2?
Oh, 2.
Well,
-2 times 2
minus
is like
4.
-4.
Okay, there you go. And what's the y's in the numerator now?
I can't read that from here.
Y to the third to the -2. Let me blow it up.
That's -6. So.
All right. So we got a y to the -6. Now let's apply it to the bottom. What's 4 to the -2?
The -8.
Let's don't multiply it out yet. Let's do it one step at a time. It's 4 to the -2 is what it is. Okay, and then the bottom x is what?
4 to the -8.
X to the -8?
Yeah.
Like that? Okay. So now I've removed the parentheses. Now I'm ready to combine everything. Well, everything has a negative exponent, so let's just switch it all. I'm going to put the 3 squared down there. I'm going to put the x to the 4th down there. I'm going to put the y to the 6th down there. I'm going to put this 4 to the +2 up there. I'm going to put this x to the +8 up there. Now come up with your numbers. That's 16 over 9. With me?
Yeah.
What's the net x's when you combine those two?
X to the 4th.
And what's the net y's?
The y to the 6.
There's your answer. Notice I'm using the same methodology every single time. And I'm doing one step only every single process. I'm never doing 2 steps at once, not even squaring the 4. Okay?
Yeah.
All right, let me see the rest of these.
Mom, can I have breakfast? Sure. No, I'll have a muffin.
The next mistake on 11, it looks like.
Yeah. Here, let's just try and get as many of them done as we can.
I understand, Sam. It's just that's not the way I tutor. I don't take other people's tests for them.
Yeah.
The only way I tutor is to try to get you to understand it. That's the only way I'm going to do it.
Okay.
I'll do it as quickly as I can, but it doesn't do me any good if you don't understand what's going on. Okay. When you're adding polynomials, you just add all like terms. That's all you do. So these parentheses are not needed, either one of them. So how many total x cubes do you have?
Thanks, Mom. X cubed is like...
2 there, and you got 4 there. How many total do you have?
Like 6.
6x cubed. How many x squareds do you have?
We have like 3.
Okay, so we got plus 3x squared. How many x's do you have?
-7.
Good. And how many numbers do you have?
7.
That's all you do. Now, this problem would have been tougher had it been a subtraction, because if it was subtraction, you would have had to change the sign on all these things that are in that parenthesis. But as long as it's addition, you can just drop all four parentheses instantly without changing anything, and then just combine all the terms. Okay, so on number 12, you never need the leading parenthesis, not unless it's being exponentiated or something. So I can drop those immediately. Okay, so I'm just going to write that without the parentheses. Now we do have subtraction here. So in order to remove the second set of parentheses, what do I write?
Could you like distribute?
Yeah, you distribute that negative sign to every term. So when you distribute it to the plus 7x cubed, you get minus 7x cubed. When you distribute it to the next term, what do you get?
Negative 2 squared.
Negative 2x squared. And the third term, what do you get?
Positive 3x.
And
Minus.
there you go. Okay, now combine all the x cubes terms. What do you get?
You get negative 3x cubed.
Combine all the x squared terms.
3x squared.
Plus, need the plus sign. I can't write 3x squared. It wouldn't have any meaning. What I'm writing is a polynomial where every term is being combined with another term. Excuse me, that was a cube. That was a cube there. 3x squared. Okay, how about the x's?
6x.
Plus 6x. And the number?
Minus 7.
Okay. You see why it doesn't make any sense if I don't put the plus sign there? In other words, if I don't put the plus sign there, that thing has no meaning at all. I don't even know what I'm looking at.
Yeah.
Now, when you're writing a polynomial, every term has to have a sign in front of it. There's no such thing as assuming a plus sign.
Yeah.
All right. Go to next. Pretty long test. This an hour-long test?
Yeah.
This is very similar to an earlier one. This is what I call a quadratic in disguise. Do you see why I call it that?
Yeah.
Because this term is squared to get this term. And that's what a quadratic is. Normally a quadratic has an x there and an x squared there. But you can treat it like a quadratic, even though it's a quartic, you can treat it like a quadratic. And it's going to factor, you're going to factor it similarly. You're going to break up the x to the fourth into x squared and x squared. Both signs are going to be negative because that's the only way you can produce a positive 12 there and a negative term in the middle. Factors of 12 that add to the number 7 are 4 and 3.
Didn't I get that right?
Oh, I see a minus 2 over here. The reason you didn't get it right is you didn't keep factoring it. In other words, I can factor x squared minus 4 down to x minus 2. That's difference of perfect squares times x plus 2. And in fact, I can factor that. I don't know why she put her purple mark just there. It should have gone there also, because I can factor this down to x minus square root of 3 times x plus square root of 3. Now, maybe she doesn't need you to do this part because that's not really the difference of perfect squares. That's still the difference of squares, and it still can be factored the way I did it. So
Yep.
this gives you all 4 solutions. And remember, we started with a quartic, so we would expect 4 solutions. It's just that we treated it like a quadratic. All right, 16. Make sure you know how to do these groupings. This is tough. Everybody makes a mistake on this one, and I'll show you why. First of all, in order to be able to do a cubic, the ratio of the coefficients has to be the same, right?
Yeah.
So 1/3 has to be the same as -4 divided by -12. And it is. So they are the same. That means I can group it. Here's the thing. When I group it, by putting parentheses around the first 2 terms, and then putting parentheses around the second 2 terms, the whole idea is to not change it. If I change it, I've made a mistake. What goes in this second set of parentheses? Is it a -12 or a +12?
Minus.
If I put a -12 and then I remove the parentheses, it turns that into a +12.
Yeah.
So it's got to be +12. So I can't just go up there and add parentheses. That changes it. So whenever you have subtraction taking place between the 2 binomials, you have to be very, very careful that you get the sign right. Okay? Now, if you look at what the second row says, it's exactly the same as the first row, and that's the point. Don't change it. Make sure it's not changed. Now, what's the greatest common factor that comes out of here? The first parenthesis.
X.
X squared. Leaving behind x plus 3. Notice that those 2 multiply to that. Always be checking.
Yeah.
What's the greatest common factor that comes out of the second set of parentheses?
4.
Leaving x plus 3. Now, this is very important. When you're solving a cubic by grouping, that binomial has to be the same as that binomial. If it's not, you've made a mistake.
Yeah.
Okay? Had you made that mistake where you put -12, this would have come out to be x minus 3. This was still x plus 3. That tells you you made a mistake. You should go back and figure out where you made it. Okay? So that's a thing to look for here, is the fact that these 2 binomials have to be the same. Now, can I factor anything out of that expression?
No.
Well, I can factor out an x plus 3. That's the greatest common factor. So I factor out x plus 3. What's left over?
Like x squared minus 4.
Correct. And then I can factor that down further into what?
X minus and x plus.
X minus what? And x plus what?
X squared minus 2 and x
No,
squared.
it's x minus 2. In other words, these are always the square roots of that. Square root of x squared is x. The square root of 4 is 2. And then the next part is always just the conjugate of it.
Okay.
So those are my 3 linear factors, and you know what the 3 solutions are. -3, +2, and -2.
Yeah.
Which problem was that? That was 18? Yeah, that was 18. No, it wasn't. No, that was 16. That was 16. Yeah, and You got it correct, you just didn't complete the factor. In other words, you got x plus 3 times x squared minus 4, which is correct, but you got to factor that further. All right, 18. Can I do this by grouping?
Yes.
Yes, you can. Okay, so it looks like you got to this step right here, okay. So here's what I'm looking at that I think I see. X squared times x plus 3 minus 16 times x plus 3. Now take this further down. In other words, what's the next step after this?
Put it.
What's the greatest? Look for a greatest common factor. Is there a greatest common factor in that entire expression?
Minus 4x plus 4.
No, hold on. Greatest common factor is that.
Right.
So let's take it out. Let's factor it out. What's left over?
X squared minus 16.
Okay, now, the only reason you lost points is because you didn't factor this fully. That's, again, difference of perfect squares. So how does that factor?
X plus 4, x minus 4.
Okay. What are your solutions?
4, negative 4, 3.
Not 3. Negative 3. You want it to negative 3?
Yeah.
In other words, your 0 is always going to, you set x plus 3 equal to 0 to find your 0. And that means x is equal to minus 3. You got the minus 4 from that one, and you got the plus 4 from that one. With me?
Gotcha.
All right.
Yeah.
19, long division. Okay, not that hard. Let me set it up. 2x minus 5 divided into 4x to the fourth plus 12x to the third minus 19x squared minus 72x minus 45. Now, I'm not missing any powers of x here. Okay? Got an x to the fourth, x to the third, x squared, and an x. If I was missing any of them, I would have to put in a dummy variable. In other words, if I didn't have 19x squared, I would put in a 0x squared. Got to have a spot for every degree of x below 4. Okay?
Yeah.
What's the first step in this long division?
Multiply.
Long division. Got to divide. Not doing it synthetically. We got to divide the very first x term into the very first x term. That's always the first step. So what is 2x divided into 4x to the fourth? Which is the same as saying 4x to the fourth divided by 2x. What is that?
Wouldn't it be 2x to the third?
Yeah, so that's what goes there. And that's the first step. Always forget the minus 5. Just divide the first variable term into the first variable term. Now you multiply. Whereas now you take this 2x cubed and you multiply both terms. Okay, so 2x cubed times 2x, we already know that's 4x to the fourth, which it has to be if we did our math right. Now what? 2x cubed times minus 5.
10x cubed.
Minus 10x cubed. You get one sign wrong, you're getting the wrong answer. So you have to be extremely deliberate when you do these. Now subtract. Long division is a process of subtraction. Well, 4x to the fourth minus 4x to the fourth, that's 0. What's this going to be?
It's going to be 22x cubed.
I don't need the plus sign in front of that because it's presumed. I don't need the 0. Okay? Now repeat the whole process from start. Well, first of all, yeah, repeat the whole process. No, bring down the 19. When you do long division, you bring down the next term. Like that, right?
Yeah.
Now repeat. That's all it is. It's repeating until we get to the final answer. So what's 2x divided into 22x cubed?
11x squared.
Okay, and that's a plus. You do need the plus sign there. Now, what do I write down here?
22x cubed minus
55 x squared. Now subtract.
Negative 70.
No, remember I'm subtracting.
Oh, right.
So I'm subtracting a minus 55, which is the same as adding a plus 55.
Yep.
So I get a 36x squared down there. Positive.
Okay.
Okay? Bring down the next term, minus 72x, and repeat. It's just a repetitive process. I could have 100 terms under here, and it would not make it more difficult. It's just more arithmetic, that's all.
18x.
Plus or minus?
Plus.
Okay, you do have to specify the sign here. You can't just write 18x. Doesn't mean that. It's part of a polynomial. If it's part of a polynomial, you always need the sign except the first term. Now when you multiply, you get 36x squared minus 80x.
Yeah, 80x.
Now subtract, what do you get?
You get 8x.
Bring down the next term.
Yeah.
That's a minus 45. And now repeat again. It's always a repetitive process. You're just doing exactly the same thing you did at the beginning. Divide 2x into 8x.
5.
How about 4? That's a plus 4.
Yeah.
Now multiply, and you get second.
Negative 4.
So you get 8x there, minus 20, subtract,
25.
negative 25, and that's your remainder. Okay? So you can either give this as an answer with a remainder of minus 25, but what a remainder really means is it's minus 25 divided by your divisor, 2x minus 5. So my answer is that polynomial, the quotient, minus 25 divided by 2x minus 5. And that's the correct way to write the answer. Not necessarily with a remainder. You don't need the R letter. Just make that remainder as part of the answer.
Okay.
Okay? All right, let's see what else we got here. You let me know when you have to leave. It's almost 8:30.
Okay.
We just did 19, right? Yeah.
Yeah.
Okay. Looks like the process you did was almost correct, except this should have been 2x cubed. Okay, let's divide this 20 synthetically. Hold on. Set it up. Let's see if I see your setup. Okay, you got the -3 in the box. You got across the top 2, 3, 0 for the missing x squared term, 40, and 93. Now, synthetic division is an additive process. That's the beauty of it. Okay, so go through this with me. What goes here?
2.
What goes here?
-6.
Here?
3.
Adding,
3.
you're adding these two numbers. Goes here?
+9.
Goes here?
+9.
Goes here?
-27.
Goes here?
And -67.
I'm adding 40 to a -27.
Oh, 20.
13.
13.
Uh-huh. And finally, what goes here?
I'm not sure.
3 times 13 is -39. -3 times 13. And then finally, that is 54. That's your remainder. That's also what the function would evaluate to. Okay? That also means that that's not a factor of that. If that was a factor of that, we would have gotten a 0 remainder. The fact that we got a number tells you that if you substitute -3 in for this polynomial, you would get 54.
Yeah.
All right? What next? I can't see if 21 you lost any points on or not. Yeah, you did. Okay. All right. 21. Can I group 21?
Yeah.
No, you can't. Ratio of the first two terms is 2 over -9. The ratio of the second two coefficients is 1/12.
Okay.
Okay? So you cannot group it, which means you're left with the only other alternative, which is the rational factor theorem. This is a 20-minute problem. We don't have time to do a 20-minute problem.
Okay.
You understand the difference between being able to do it by grouping, which is easy, and having to factor it to find the zeros. You're not allowed to use a calculator here, right?
Yeah, you can.
Ah, well then I'm sorry. I put this into your calculator and find the zeros. That's all you have to do.
Yeah, I don't know if I actually did that. I was allowed to.
Well, all of this stuff you're doing here, I can't really tell what you're doing, but there is a very complicated process called the rational factor theorem that you have to apply here to find the zeros if you can't use a calculator. If you can use a calculator, then put it into your calculator and look for the zeros. There's a function on there that tells you it'll find their zeros. If I put that into Wolfram Alpha, it'll give me the zeros. I won't have to do any more work. It'll give me all 3 zeros. Okay? But if you're not allowed to use a calculator, like I said, this is a 20-minute problem. We better go on.
Yeah, let's just go on. I'll do that later.
Well, do you know how to do it?
Yeah. I'll put it in the calculator.
Okay. Same for 22. Anytime you have cubics or quartics that you cannot group, and there's no group in quartics, cubics are the only ones that sometimes you can group them. Quartics, you have to apply the rational factor theorem if you're doing it manually, and this is also a 20-minute problem because possible solutions are all of the factors of 60. Well, you can imagine how many factors of 60 there are.
Yeah.
And each one of them is a possible zero. So I would have to take each one of them by trial and error, synthetically divide, and see if I produce a zero. That's why it's a 20-minute problem. If you can do it in your calculator, do it, because then all you have to do is get that function in your calculator, and your calculator will tell you the zero. All right, let's look at 24. This is a very common problem, 24, where they give you some zeros and they want the polynomial that you would have started with. So this is doing it backwards. They're giving you the zeros and you have to come up with the polynomial. Well, what are the zeros? They gave us 3 and minus 2i. Do we know any other zeros?
No.
Complex zeros always come in pairs. If they tell you that minus 2i is a zero, then plus 2i has to be a zero also. If they tell you that 2 minus 3i is a zero, then 2 plus 3i is also a zero. That's the way imaginary zeros work. You never find an imaginary zero all by itself, ever. They always come in pairs. So here's our 3 zeros. What are our 3 linear factors? You wrote x plus 3, but if 3 is a zero, x plus 3 does not give, that's not the linear factor. It's x minus 3. It's always x minus your zero. So that's one factor.
And then the plus or minus 2i.
Right. X minus 2i is another factor, and x plus 2i is another factor. Now, what you do from here is multiply that by that, take your answer, multiply it by that, and you have your third degree polynomial. Make sure you know how to multiply those two together?
Yeah, it's basically they become squared and it flips to like...
Okay, that's like the difference of perfect squares. So what these two, 1 and 2 multiplied together give you are x squared minus 4i squared, and I squared is -1, so it gives you that. And now I have to multiply that by x minus 3. That's simple foiling. You get x cubed plus 4x minus 3x squared minus 12. Put it in proper order. There's your answer.
Okay.
The most important mistake you made on this problem was taking your 0 and turning it into the wrong linear factor. You turned it into x plus 3. Remember, when you have the linear factor and you're trying to find the zeros, it's always plus 3, right? Well, when you're going in reverse, make sure you do that same process. All right, let's see. What else?
So I think I'm going to have to go.
Okay, and then everything else is extra credit anyway.
Yeah.
Oh, there's a whole other test here.
There's a lot more.
All right. Okay. I will let you go. Have a good day, and I hope I've been helpful. Yeah, and all right. I won't say anymore. I'll talk to you next time, Sam.
Sounds good.